Okay, picking up where we left off with the week 8 notes. We have one more example on page 81 for grouping. Grouping is really essential to what we're going to do for the rest of the notes for today, so I wanted to leave this one example to freshen your mind at the beginning of this video before we move on to what we're going to need it for the rest of the notes. So remember, so far in this set of notes for week 8, we've learned about factoring. So there's 3 types of factoring we've learned so far. First being GCF, which stands for the greatest common factor. You always want to see if something that you are factoring has a GCF to start. If it has a GCF, you are going to do the GCF type of factoring. If it doesn't have a GCF, from that point on you want to count your terms. If it has 2 terms, you are going to do DOPS, which is the second method that we learned. But in order to do DOPS, it also has to be in the correct setup. So what I mean by that is DOPS stands for difference of perfect squares. That's the setup. You need subtraction, which is another word for difference, of 2 perfect squares. Remember, to be a perfect square, it's the answer you get when you multiply 2 numbers by themselves. So like 3 times 3 is 9, so 9 is a perfect square. And then for a variable to be a perfect square, it just needs to have an even exponent. So if you have that set up, you're going to use the DOPS method. And then the third type of factoring we went over in the first video was grouping. Very easy setup. If it has 4 terms, you do grouping. So let's do this last grouping example. I look at question 257 and I see 4 terms. So right off the bat, I know I have to do grouping. Now it's called grouping to sort of help you out with the original step where you're going to start is by grouping your first 2 terms together and grouping your second 2 terms together. Now within each group, you are going to use the GCF method. Seems kind of crazy because this isn't actually GCF method, it's called grouping, but you do GCF within it. So in my first group, first look at your numbers. I have 4 and 2. The GCF between 4 and 2 is 2. Then you have to look at the variables. This one's a little bit tougher than ones we've done before, so just stick with me. First for that x squared. Remember, x squared means x times x. And then my second term, 2xy, has only 1x. So they have 1x in common, so my GCF is going to have just 1x in it. They also have a y in common, so my overall total GCF is 2xy. That is the greatest thing they all have in common. So for GCF factoring, you take that 2xy and you put it out in front of your parentheses and you divide. 4 divided by 2 is 2. X squared divided by x, kind of the same idea as what we did off to the side, but I have 2 x's on top divided by 1x on the bottom. So those are going to cancel and it's just going to leave me with an x. And then these y's cancel. So I get 2x when I divide those first term. And then here, if you notice, 2's cancel, x's cancel, y's cancel, and you're left with nothing, but you always have to put a 1 there when everything cancels, so that when you distribute this back through to check, you get that 2xy back. All right, now let's GCF the second group. This one's much easier. Between 2x and 1, if I think about the smaller number here, it's 1. The only number that goes into 1 is 1, so my GCF has to be 1. Now I know in the very beginning of the last video when we talked about GCF factoring, if it has a GCF of 1, I said don't ever do it. This is the exception, and I'll show you why when we go to write our answer. But when you're doing grouping and you have to take out a GCF, you absolutely need a GCF, even if it's 1. So I take that 1, I put it out in front, and when you divide everything by 1, easy peasy, it's just exactly what it started with, 2x plus 1. Now remember what we talked about with grouping in the last video. These must match up. It's actually really nice that they have to match up because it's kind of like a check for you. If they don't match up, chances are you took out the wrong GCF somewhere along the line, or you divided wrong, or something went wrong and you would just go back and fix it. But because they do match up, I'm ready to write my answer. That 2x plus 1 that matches up comes down. Once you bring it down only once, it's gone. Now look at what's remaining, 2xy and then that 1. Here's why that 1 is so important. When I go to write out this next factor, I'm supposed to put the 2 GCFs together, and I need that plus 1 there to get me the correct final answer. Remember, all of these can be checked by double distributing. So you can go off to the side and check it, and this 1 is necessary for it to end up working out. Okay, so with grouping, if it's GCF of 1, absolutely take it out and put it there so that you can put it in your answer. All right, I'm going to jump you around a little bit. We're actually going to jump past page 82. We will return back to it, but I want you to go to page 83. So on page 82, the method that we're skipping over temporarily is called Trinomial Easy. So Trinomial Easy doesn't necessarily mean it's an easy method, but it's an easier way of doing this method we're about to learn right now. So I'd rather teach you this and then kind of jump back so you can see how the easy method applies to this. So now that we've went over the 3 different types of factoring, again, so far GCF, DOPS, and grouping, we're going to jump into this next one, which is trinomial. I don't know if you've ever heard it before. A trinomial has 3 terms. Think about it in terms of a tricycle. A tricycle has 3 wheels. A trinomial has 3 terms. Now, we also talked about this, but I'm going to bring it up again because it's super important for this right here. Ax squared plus bx plus c is the standard form of a quadratic. Remember, a, b, and c are just numbers. Okay? So, when are you going to use this trinomial AC method? Ultimately, if it has 3 terms, and this part right here is crucial. A, which is this first number right in front here, has not a 1. That was not a good way of saying that. It's not 1. If you look at all the examples on this page for trinomial AC, notice the number in front of x squared here is a 2. Here it's a 4. It's a 15. It's a 21. Whatever it may be, it's not 1. So when we're factoring and you're just told to factor, you go through, you see if it has 3 terms. If it has 3 terms and you notice this number again in front, that A is not a 1, this is the method you are going to do. Now, it's called AC for a reason. All of these have a nice way of helping you out, like the title of the factoring method has a nice way of helping you out with at least a step somewhere along the line. A, C, technically is 2 letters right next to each other. We've talked about that before. If they're right next to each other with no symbol between them, it means multiply them. So that's the hint for you to do this first step you notice right here. You're going to start by multiplying A and C together, and then I'll walk you through the rest of the steps as we go on. Okay, so here we go. It's a long process. This is probably the toughest method, so please stick with me. For 263, again, I count that there's 1, 2, 3 terms. That tells me this is a trinomial, and I'm going to do AC because I have that 2 circled. A is not 1. So I do A times C to start. 2 times 3 is 6. Now you might be thinking 2 and 3, why are those A and C? Just a reminder from up here, A is the first number, C is the last number. So A times C is always going to be that number in front of x squared times the number by itself. So I want you to write that 6 off to the side. What we are going to do with that 6 is list the factors of 6 like we did in the very beginning of the last video. So what I mean by that is 1 times 6 and 2 times 3. Those are the only factors that will some way multiply together to get me 6. Now I know it could also be 3 times 2 and 6 times 1. You don't have to reverse the order of them. You just need to list all of the factors. Okay, now what you have to do here, what your goal is, and it's actually kind of cool. It's like a little math puzzle. You guys probably won't think it's cool, but I definitely think it's cool. From this list of numbers that multiply to 6, you also have to find the pair that meets the criteria of adding to this middle number, 2. So again, your ultimate goal here is to pick the pair that multiplies to this number, 6 in this case, AC, and adds to this middle number, which is a positive 5. If I add 1 and 6 together, I get 7, so that doesn't work. If I add 2 and 3 together, I get 5. This is the ideal pair I want. It's the pair that multiplies to 6 and adds to 5. Here's what I'm going to do with these 2 numbers. It's a process that just needs to be memorized, so again, please just stick with me. You start by bringing down your first term, so 2x squared. That 5x that I have circled in green is no longer going to be 5x. We are going to split it up into the 2 numbers that we picked over here off to the side. So instead of writing plus 5x, we are going to write plus 2x plus 3x. Okay, now the last step in the setup is to bring down that plus 3 at the end. So it seems kind of silly. What we literally just did was unsimplify what we had. If you were given what we just wrote in blue here with the 2x and the 3x, you would normally combine those like terms to get you that 5x back, but we're unsimplifying in the same way that we're undistributing. So it's kind of weird. We're like breaking it apart, but here's why. So everything that we just did to set up this problem was new. From here on out, it's not new anymore. So that's really the gist of all you need to know about trinomial AC. What we're going to do from here depends on how many terms we have. The whole purpose of unsimplifying that 5x and breaking it up like we did right here into the 2x and the 3x was to create 4 terms. Now hopefully we know with 4 terms at this point, the second you see 4 terms, you're going to use grouping. So grouping is really crucial for you guys to know. We're going to practice grouping a lot more throughout the rest of this video. I'm going to start by doing it right now. So I grouped the first 2 terms together and I grouped the second 2 terms together because I set it up so that I can. I have 4 terms now. In my first group, I'm going to take out a GCF just like I did with my grouping example. The GCF in my first group is 2x. So that 2x comes down with a parenthesis. And then I divide. 2 divided by 2 is 1. You don't have to put the 1 there. And x squared divided by x is x. Now here, everything cancels just like it did in that last grouping example we did, but that means I need a plus 1 there. Next group has a GCF of 3, so I'm going to divide them both by 3 and put that 3 out in front. When I divide, 3 divided by 3 is 1, or they cancel and it's just x. Either way is fine. And then 3 divided by 3 is also 1. Now, just like the old method of just grouping all by itself, this and this match up, which tells me I've done it right so far. So my final setup, I'm going to bring that down, 1x plus 1 or just x plus 1. When you bring it down only once, it's gone. So then I have 2x and 3 left over. I put those together, 2x plus 3, and I'm done. Again, all of these can be checked by distributing. All of my checks are on my key on Blackboard. If you want to see how the checks are done, just go check it out there, but they're all done the same way. We've already done a couple of these together. All right, let's try it again. So I know this whole page is dedicated to trinomial AC. I just want you to get through that thinking process of why it's that method. So for 264, I have 1, 2, 3 terms, and that 4 that's circled tells me this is going to be the AC method because A is not 1. We'll go back and do examples where A is 1 in a minute. So 4 times 5 is how I start this. A times C is 20. I'm going to start by doing exactly what I did in the last example and listing the factors of 20. If it helps you guys to keep everything organized, I always start with 1. 1 times 20 is 20. Then I move on to 2. 2 times 10 is 20. 3 doesn't go in, so I don't list 3. And then 4 times 5 is 20. That way you don't start at 4 times 5 and then maybe forget 2 times 10 and then you miss something that you need or whatever it may be. It just helps you organize your work a little bit. You know, before we go on any further, I want to bring you to the top of the page and we're going to write a couple of rules. Hopefully rules we already know, but stuff that we definitely need to be familiar with for all of these examples. Finding those numbers using that, that math puzzle I just think is so much fun. Okay, so something you need to know. Positive times a positive will always get you a positive, and a negative times a negative will also always get you a positive. If you have same signs multiplied together, it's going to multiply to a positive number. Okay, what you also need to know is if you have opposite signs, so a positive times a negative or a negative times a positive will always get you a negative answer. So same signs multiplied together get you a positive answer. Opposite signs, no matter what the order, positive times negative or negative times positive, will get you a negative answer. All right, so for this first example that we did, we had a positive 6 that we had to multiply to, and we used a positive times a positive because we were adding to a positive 5. Now, we have a positive 20 that we're multiplying to. So it's either a positive times a positive or a negative times a negative. But in this case, we're adding to a negative 12. So your goal here is to pick a pair of numbers that multiplies to positive 20 and adds to negative 12. Take a second to try and figure out what that pair is going to be. Okay, hopefully you came up with 2 and 10. Positive 2 and positive 10 adds to positive 12, so that doesn't work. I need negative 2 and negative 10. Because your whole answer depends on picking the correct pair here, I always recommend you double check. Negative 2 times negative 10 is positive 20. That works. Negative 2 plus negative 10 is negative 12. It also works there. So just multiply them together, make sure you get this. Add them together, make sure you get this. If you do, you're perfect. Okay, so I'm going to set it up exactly like I set up the first one. What is nice about factoring is the process doesn't change. So I still start by bringing down the first term, 4x squared. Now I'm going to split that middle term up into the two numbers that I chose. So instead of minus 12x, I'm going to write minus 2x minus 10x. And then the plus 5 comes down. So a question that I usually get, and please do not write what I'm about to write in yellow, is if these two can be reversed. Can you write minus 10x minus 2x instead? Absolutely. You would get the correct answer. Your work will look different than mine, but it'll still get you the right answer. So it does not matter what order you write those two terms in. Okay, so at this point, I'm done setting up my AC method. I now have 4 terms, and grouping is going to take over. So I group my first 2 terms together. I group my second 2 terms together, making sure I get a negative sign in that second group. And I GCF each group. So I take my first group. My GCF is 2x. 2x comes out in front. 4 divided by 2 is 2. And x squared divided by x is x. Now here, 2's cancel, x's cancel, but I need to replace it with a minus 1. Make sure you bring down that minus sign. It's like a negative 2x divided by a positive 2x. It's going to get you a negative 1. All right, now something that's a little bit tricky here, and it all has to do with this negative symbol right here. I'm looking at my 2 terms. I have a 10x and a 5. I'm thinking my GCF is 5 because 5 is the biggest number that goes into 5 and 10x. If I take out a GCF of 5, I have negative 10x divided by 5, which is a negative 2x. Now, hopefully you're noticing that thing I told you about grouping so many times. They're not going to match up. Okay? If they don't match up, think about what's happening here. You need a positive 2x and it's a negative 2x. The only way to make that work is to divide by a negative. So your GCF has to be a negative. If you now divide negative 10x by negative 5, it's a positive 2x, which is perfect. Also, same thing here. I have a positive 5 divided by a negative 5. That's a negative 1, and I needed it to be a negative 1, so that works out. So 2x minus 1 and 2x minus 1 do match up now that I've made that GCF a negative 5. So I'm ready to write my answer. That 2x minus 1 comes down, but only once, and now it's gone. 2x minus 5 comes down in 1. And that's my answer. So hopefully you're really getting the hang of grouping right now. It's those first couple of steps that's new for this method of AC trinomial. All right, this next one is a great example. Okay, so I count my terms, 1, 2, 3. I know it's trinomial, and I know it has to be this AC method because of the 3 in front. So I start by multiplying A and C together. Careful with this one because C is a negative 10. So A times C is a negative 30. What I want you to do for now is just list the factors of positive 30, and we'll talk about that negative in a little bit. So 1 times 30, 2 times 15, 3 times 10, and 5 times 6. think about the goal. We're trying to multiply to a negative 30, which means the pair that I pick has to have one positive number and one negative number. It doesn't matter the order, but they have to have opposite signs. And we're trying to also pick the pair that adds to this middle number, negative 13. So take a second to try and pick the pair that works. Don't move on, just take a second to try and figure it out. This one's definitely a tricky example. Okay, the reason this one's tricky is because a lot of people see the 3 and the 10 and immediately think 13. But in order to make that a negative 13, it'd have to be negative 3 and negative 10. Yes, negative 3 plus negative 10 does equal negative 13. But negative 3 times negative 10 is equal to a positive 30. And we don't have a positive 30, so that pair doesn't work. It's tempting. It doesn't work for both criteria. It has to fit that puzzle that we're trying to figure out. The pair that you actually want to use here is 2 and 15. And you might be thinking 2 plus 15 is 17. You are right also. But remember, we're multiplying to negative 30. To multiply to a negative, I need one of my terms to be positive, and I need one of them to be negative. So that quick double check. 2 times negative 15 is negative 30. That works. 2 plus a negative 15 is negative 13. It can't be a negative 2 and a positive 15 because that's equal to positive 13, and that doesn't work. I need it to be negative 13. So there's a lot to consider. There's a lot of mental math to do. Use your calculator if you need to, but picking this pair determines your whole answer. Let's say you did pick negative 3 and negative 10 and you were confident about that pair. When you go through and you do this whole process over here, these at the end that are supposed to match won't match. Okay, these right here that are supposed to match, like we just talked about, they won't match up, and that's a big red flag to you. If they don't match up, you have to go back. Maybe you picked the wrong pair. Maybe you divided wrong. Maybe you took a wrong GCF somewhere. It's worth going back and double checking if those don't match up. It's a really nice check in this process. All right, now that we have our correct pair, 2 and negative 15, I'm going to use the same setup we used for the last two examples. Bring down the first term, 3x squared. Negative 13x is going to get split up into the two numbers I picked, so plus 2x minus 15x. Remember, the order of those does not matter. And then the minus 10 comes down. That's the AC setup. I'm now in my 4 terms, so I'm ready to continue with grouping. I really hope at this point we are getting the hang of grouping. We've done it a lot at this point. Okay, so my GCF of the first group is just going to be x. You can absolutely put 1x. That will not be wrong. When I divide 3x squared by x, I get 3x. And 2x divided by x, my x's cancel and leave me with just a plus 2. Oh guys, here's that situation again where I have a negative term and I need it to become a positive term. That tells me that my GCF is going to be negative. If you don't see it right off the bat, just think about the positive GCF and do exactly what we did in the last one. Realize that you had to add that negative once we got there. Okay, so between 15 and 10, my GCF is 5, and again, I need it to be a negative 5 so that it'll end up matching up with this guy over here. So negative 15x divided by negative 5 is a positive 3x, which is perfect. And then negative 10 divided by negative 5 is a positive 2, and we are good to go. These match up exactly how I needed them to. Once they match up, I bring down the 3x plus 2, gone. Then your other factor is going to be putting together those two GCFs, or what's left, x minus 5. Now, I didn't really mention it in the last one. Super important. If this is a negative 5, you bring it down as a negative 5 and it serves as a minus. Same thing here. Because this GCF was a negative 5, it comes down as a minus 5 in your answer. And a reminder, all of these can be checked by distributing. All right, let's do a couple more examples and then we'll jump back up to that last page. So for 266, Again, knowing what method to use and when to use it, I have 1, 2, 3 terms here, and that 15 in front of my squared variable tells me this is the AC method. So I start by doing A times C, and again, C is negative. So off to the side, I'm going to find the factors of negative 15. When you're finding factors of a negative, you want to consider the positive factors for now, just like we did in the last one. So it's just going to be 1 times 15. We'll think about the signs later. 2 doesn't go into 15, so I move on to my next factor, which is 3 times 5. And that's it for 15. Now, to multiply to a negative 15, I know these need to be opposite signs. If I work with this positive and negative 15, or I flip-flop them, negative 1 and positive 15, either way, I'm in some way going to get a 14, which is not what I need. Your goal is to add to a positive 2, so it's definitely going to be 3 and 5. You need to figure out which of those numbers is going to be positive and which is going to be negative to make this work. So to get a positive 2, it's going to be a negative 3 and a positive 5. Because, again, do that double check before you do this long process. Negative 3 times positive 5 is negative 15. That checks out. And negative 3 plus 5 is a positive 2. That checks out. So take a second right now, pause your video, and set this up on your own. It will benefit you. Practice makes perfect, remember. So go ahead and pause and set this up, and then press play when you're ready. I'm going to continue on. Okay, so the setup for this is going to be to bring down that 15a squared, split up that plus 2a into minus 3a plus 5a, and the minus 1 comes down. If you did pause the video when I told you to, and you have the 5a and the minus 3a reversed, you are still correct. Your work will just look a little different. Okay, so now I have 4 terms, so I'm ready to group. I group my first 2, and I group my second 2 terms. My GCF of the first group is 3a, so I take that 3a out, bring it down in front of a parentheses, and I divide. 15 divided by 3 is 5, a squared divided by a is a. Here, everything cancels, but I still need to put that minus 1 there. Now what's kind of nice in my next group is it has a 1 again. If I have a 1 in my grouping problem, my GCF is instantly going to be a 1. And remember, you must take it out because you need this 1 right here for your final answer. So 5a divided by 1 is 5a, and negative 1 divided by 1 is a negative 1. And luckily for us, these match up. Yours should have matched up too. 5a minus 1 comes down, gone. Then you take your 2 GCFs and put them together, 3a, and that's a positive 1, so this is going to be plus 1. Alright, so the next one, 267, has slightly bigger numbers. I'd again like you to pause the video and try this one completely on your own. So it is AC because I have 3 terms and A is a 21. So you start by multiplying A and C together and go ahead and pause your video and give it a try. Once you're done, come back and play. Alright, so I'm going to go through this problem. Hopefully we get it right. A times C is going to be negative 42 because remember C is a negative number. Positive 21 times negative 2 is negative 42. So I list my factors of 42. I have 1 and 42, 2 and 21, 3 goes in, believe it or not, 14 times, and 6 times 7. So something you might be wondering at this point, if you're really good with your mental math, you don't need to show this whole list. If you think you know what the numbers are that you already need to add to that middle number, you don't have to write the whole list. That is entirely up to you. I advise you to write out numbers that you think it could be so you don't run into an issue like we had down here where maybe you thought it was 3 and 10 and then you get the whole problem wrong. So it's up to you if you want to write the whole list or not. You won't lose points if you don't. All right, so these are all the numbers that multiply to 42. I'm trying to pick the pair that adds to this middle number here. Now the number in front of that x is just going to be a negative 1. So your goal is to add to negative 1 and multiply to negative 42. Hopefully we came up with a positive 6 and a negative 7. Do that double check in your head. Positive 6 times negative 7 is negative 42. and positive 6 plus negative 7 is the negative 1 I need it to be. So I go ahead and I start my setup. 21x squared comes down. Again, same setup we've been doing. That negative 1x becomes plus 6x minus 7x, and then the minus 2 comes down. You've got grouping all set up for you, ready to go. So you group the first two together, group the second two together. Now the GCF for the first group is a little bit more complicated than it's been for a lot of the examples that we've done. Usually it's the smaller of the two numbers. This one's GCF is not 6 because 6 doesn't go into 21. The biggest number that goes into both of these is 3. So my overall GCF is 3x, and I go ahead and I take that down in front. 21 divided by 3 is 7, and x squared divided by x is x. So I get 7x there. And my next one, the x's cancel, and 6 divided by 3 is 2. Now remember the goal. I need this to match up with what I get over here when I have this next group that I have to take a GCF out of. Between 7x and 2, they don't have anything in common other than a 1. But they're both negative right now, and I need them to become positive. So that tells me my GCF needs to be a negative 1. Watch what happens. When you do negative 7x divided by negative 1, you get a positive 7x, which is perfect. It matches up over here. And negative 2 divided by negative 1 is a positive 2. Again, perfect. It matches up. Once these match, you write it in your answer. 7x plus 2, gone. And then put your two GCFs together. 3x minus 1. Final answer. Again, what's this method called? I know you answered me. Trinomial AC is correct. Okay, so for 268, I have 3 terms again. To know if I'm doing the AC or the easy method we're about to learn next, you look at this number. If it's not a 1, you do AC. So I start by doing A times C. 2 times 4 is 8. So after the side, I list my factors of 8. I get 1 and 8, and 2 and 4. So take a second to try and pick the correct pair of that list that's going to add to 3. It's not working, right? There is no pair of factors that multiplies to 8 and adds to 3. It just doesn't work, so this one can't be factored. Wow, that looks nice. Can't be factored. So I'll tell you guys right now, on a test or a quiz, every factoring question I give you can be factored. So never make can't be factored an answer on a test or a quiz, okay? This is just an example of something that doesn't factor using this method. And so that's the gist of trinomial AC. So we now have 4 types of factoring down. We're going to move on up here to trinomial easy. So same idea with that tricycle 3 wheels, trinomial 3 terms idea. If it has 3 terms, you're going to refer to one of these trinomial methods. Again, AC is done when A is not 1. Easy method is done when A is 1. So when you have a 1 in front here, if you look at all of these examples, there's no number here. There's no number here. There's no number here. All of them have a 1 in front, which simply tells you that you're going to use this easy method. So what I want to show you all first, and a lot of people like this, a lot of people don't. I usually get like a 50-50 split. If it's a trinomial, the AC method that we just learned will always work. So we're going to do this first example using both methods. I'm going to start by showing you AC with this, okay? So using the exact same process we just learned before, A times C is 6. My factors of 6 are 1 times 6 and 2 times 3. I need to, just like I did in the last page, pick the pair that also adds to positive 5. Easy peasy. It's 2 and 3. So now I go to set up my AC factoring. 1x squared comes down. I split up that middle number into plus 2x plus 3x, and my plus 6 comes down. I have 4 terms, so I'm ready for grouping. Guys, this is the same method we just did on the last page. I know it's a little bit of drill and kill, but you'll appreciate it in the long run. Practice makes perfect, remember? So my GCF in the first group is an x, so I divide both of them by x and I put that x out in front. 1x squared divided by x is just an x. 2x divided by x is just 2, so plus 2 comes down. Now my next group has a GCF of 3. Between 3x and 6, the GCF is 3. So I bring 3 down and I divide. These 3's cancel and give me an x. And then 6 divided by 3 is 2. And I notice these match up. So when I go to write my answer, the x plus 2 comes down. Those are gone. And the x and the 3 come together just like that. And this is my final answer. Now, you're probably wondering why it's a completely different method if you can use trinomial AC for any trinomial. So again, if there's 3 terms, trinomial AC method works every single time. What I'm hoping some of you may have noticed or remembered from a previous math class is the connection between your answer here and your 2 factors that you picked. I want you to take a second and circle this up here in your box. Okay? The easy method is almost like a shortcut where you can just take this setup and have your answers without doing all of this extra work. This is the AC method. Your shortcut can come straight from your answers. Once we pick 2 and 3, watch what happens. X plus your factor, so x plus 2. Then I go up here, x plus your factor, x plus 3. Notice it's the exact same answer. Now why haven't we been doing that all along? This shortcut only works when A is 1. So there's 2 different types of people when it comes to factoring. Some that want to remember less methods. Okay, if you are that person and you're like, wow, 5 different types of factoring is a lot for me to remember when and how to use each one, just think if you have 3 terms, do AC. It's a few extra steps, but it works every time. Now, the other half of the people are like, I don't want to have to do all those steps if I don't have to. So they really try to remember this shortcut right here. If A is 1, you can go straight to your answers like this. So I'm going to practice the shortcut with you again and again for the rest of this page. If you prefer AC all the time, you can practice with AC all the time for the rest of the ones on this page and just check your answer with us at the end, okay? So for 259, because I don't have to do AC, I still multiply A and C together, but notice it's always just going to be this number. 1 times that 12 is going to be 12. 1 times the last number is always just going to stay itself. So my factors of 12 are 1 and 12, 2 times 6, and 3 times 4. Your goal is to still, just like before, pick the pair that multiplies to positive 12 and adds to negative 7. Take a second to try and figure out what that pair is. Hopefully you got 3 and 4. Now positive 3 and positive 4 add to positive 7. That's a big no-no because I have a negative 7 here. So I'm going to use negative 3 and negative 4, and I'm going to be smart and just double check that those numbers work. Negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 is negative 7. This is my correct pair. Now using the shortcut, all I have to do is plug those numbers into this format. Because they're negatives, it's going to be minuses. So x minus 3, x minus 4, and that's your final answer. Now, last check I'm going to show you for any of these, but remember the check applies to all of them. Same kind of way you would check anything, but I think this might help you see the shortcut a little bit better. When I check, I distribute, so I start by distributing this x through. X times x is x squared, and x times negative 4 is a minus 4x. Next, I distribute the negative 3 through. Negative 3 times x is a negative 3x, and negative 3 times negative 4 is a positive 12. Notice why it needs to multiply to 12, because these two numbers multiplied together to get 12, and it has to add to the middle number, because when I add those two numbers together, I get minus 7x, and it does check. Think about the AC method. You split up that minus 7x into those two numbers, and then you do grouping to get to this answer. We're just going forwards and backwards over and over again. All right, this next one, I don't want you to stress too much about the setup because I won't do this to you until next week. So you won't see something like this on your quiz for the week 8 homework assignment. Okay, but it's in the wrong order. You must have ax squared plus bx plus c. We will do one more like this that's in the wrong order today. Okay, so your x squared term needs to come down first, 1x squared. Then your x term, which is this right here, comes down next, so minus 5x. Then your c, keep in mind it's a negative 24, so I put minus 24. If you don't bring the signs down with it, you're going to have a big issue towards the end. So I take this number off to the side, or I think about it as a times c. Either way, off to the side, I need to find factors of negative 24. For now, I'm just going to list the factors of positive 24. So 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Use that calculator if you need to. Now the goal here is to find the two numbers that multiply to 24, which is any of those pairs on the list we just made, and it has to add to negative 5. Take a second to try and figure out your pair. Please don't be the kind of person that sits there and waits until I just tell you. Try and think through this process on your own. Practice makes perfect. Hopefully you got positive 3 and negative 8. Do that quick double check. Positive 3 times negative 8 is negative 24, and positive 3 plus negative 8 is a negative 5. So I'm using my shortcut. Always set up just like this. The plus 3 comes down, and the minus 8 comes down. And I'm good to go. Right. Go ahead and pause the video and try the next one on your own using the shortcut if you think you like this shortcut. I'm going to just go ahead and get moving on it. So off to the side, I'm going to list the factors of negative 56. For now, that's just going to be 1 times 56. Thinking about the positive terms, I'll take the negative into consideration later. 2 times 28, 4 times 14, and 7 times 8. And you're trying to pick the pair that multiplies to negative 56, so you need a positive term and you need a negative term. But ultimately it has to add to this middle number, which is a positive 1. So the pair hopefully you picked when you paused this and did it on your own, because I know we all did, is negative 7 and positive 8. So that makes my answers x minus 7, x plus 8. And like I've said, for all of them, you guys can absolutely switch the order of these. As long as your minus goes with your 7 and your plus goes with your 8. Either one of these is fine. All right, last one. Off to the side, I'm finding factors of negative 30. You may or may not have noticed this right here. That'll come into play a little bit later. You're just going to factor it like a normal quadratic for now. So I need to list the factors of 30 underneath this. And remember the goal. You're trying to multiply to a negative 30, so you need a positive and a negative number in your pair. And it also has to add to negative 7. So again, take a second to try and figure out what that pair is going to be. Don't wait for me to tell you. Try and figure it out. Hopefully we got a positive 3 and a negative 10. Here's why. Positive 3 times negative 10 is a negative 30, and positive 3 plus negative 10 is a negative 7. So using my shortcut, my answers are going to be x plus 3 and x minus 10. But before you go and flip the page and think you're done, remember what I told you to ignore for now. That exponent of 4. If you go to check this off to the side, like a good student who wants an A, x times x will get you an x squared, and that's not what you have there. So it's a big red flag. You need it to match up with your original expression. The only way to make that work is to make each of these x squareds. So watch how that's going to work now. X squared times x squared is x to the 4th. When I keep checking, x squared times negative 10 is a minus 10x. 3 times x squared is x squared. Positive 3 times x squared is 3x squared, and 3 times negative 10 is a minus 30. So by changing those to x squareds, I made this x to the 4th, my first term that I needed, and I can combine these x squareds to get me a minus 7x squared minus 30. I went through that a little bit quickly because you're not going to have to worry about a question like that on a test or a quiz. It's just a little bit of a challenge problem to expand your knowledge. That sounded annoying, didn't it? All right, before we move on to our last page, I'm going to go ahead and give you your code word for today's lesson. Your code word for today is going to be lemon. Okay, so mark that down somewhere on your notes because it is going to come up on your quiz. You need to know these code words to prove that you watched this lesson. So code word, lemon. Now please don't pause the video quite yet because you already got your code word. The next page is probably the most important page of the lesson, so stick with me. Okay, code word is lemon. Here we go, let's go to that last page. Okay, so what we've learned so far is 5 different types of factoring. GCF, difference of perfect squares, which is DOPS, grouping, trinomial easy, and trinomial AC. So 5 different types of factoring. On your quiz for the week 8 homework assignment, it is going to be filled with 5 questions. Those 5 questions are going to consist of 1 GCF question, 1 DOPS question, 1 grouping question, 1 trinomial easy question, and 1 trinomial AC question, making up 5 questions on your quiz. Now people tell me, oh, that's really easy. You kind of just gave me like the biggest hint ever. The problem that people don't realize is that they're going to be mixed up. So the first question might be grouping. The first question might be GCF. The first question might be DOPS. So you not only need to know how to do each of these methods, you need to know when each of these methods applies. So I want you to handle these next technically 5 questions. Don't worry about 274 for now. I want you to look at these next 5 questions we're about to do as though it's your quiz. And you know walking into it that there's going to be, again, 1 GCF question, 1 DOPS question, 1 grouping, 1 trinomial easy, and 1 trinomial AC. Now before jumping into this, I want you to scroll up. I know, I'm sorry, I'm terrible at scrolling on this thing. Scroll back up to that page we skipped in the first video that tells you when to use each method. It's on 78. So flip to page 78 real quick. This is like all of the combined information and everything you need to know about all of the different methods of factoring. We skipped over it before because you knew nothing about factoring, but now it's kind of like a little cheat sheet for you. So this might help you big time to have out while you're working on your quiz. Because again, remember, your quiz is not going to have identical homework questions anymore, but they will be similar and it will be open notes. So you can use this to help you through your factoring quiz. Okay, so the types of factoring and what to look for is what I want to focus on. First, GCF, greatest common factor. If you want to just throw that on there in case you forget. You can do the GCF method with any number of terms. It could have 2 terms, 3 terms, 4 terms, 5 terms even. If it has a GCF, you do the GCF method, which tells you off the bat that you need to consider this method first. So, anytime you have a factoring example, you have to see if it has a GCF to begin. If it has one, you do that method. If it doesn't, you move on. So my advice to you after you check for a GCF is to then count your terms, because all of the other methods have to do with a certain number of terms. If there's 2 terms and there wasn't a GCF, chances are you're going to be doing difference of perfect squares, but you also need this setup as well. It's exactly what the method is called. You need the difference, which is just subtraction, of perfect squares, okay? All right. If you don't have a GCF and you count your terms and you have 3 of them, Remember, trinomial AC always works. So if you don't even want to worry about trinomial easy, which is more of a shortcut, you don't have to memorize that formula, okay? It's a shortcut. I think I said formula. I meant to say you don't need to memorize that method. Okay, it's just a shortcut. Trinomial AC always works. But ultimately what you want to know about each of them is it's a trinomial. So if you don't have a GCF and you count 3 terms, it's going to be one of these 2 methods. And it all depends on this right here. If A is 1, you can use the shortcut. If A is not 1, you have to do AC, which is basically setting it up so that it becomes a grouping problem. Okay, and then last, grouping is probably the easiest to figure out when to do it. If you don't find a GCF and it has 4 terms, you go ahead and do grouping, and that's all there is to it. And then just a reminder to you that you can check every single factoring question on your whole quiz, on your homework, on everything by distributing. All right, I'm going to slowly scroll back to that last page now that I have all of that in mind. I'm sure there's an easier way and you guys are laughing at me right now, but that's the best I know how to do it. All right, so mixed factoring, we're treating this like it's our quiz. So question 269 is the first question on my quiz. I remember what I learned in my notes, and it says that I have to find if it has a GCF first, between 9x squared and 49. They don't have anything in common other than 1. You only take out a GCF of 1 if you're working on grouping. For this example right here, it technically doesn't have a GCF, so I'm not going to do the GCF method. Next, I count my terms. There are 2 terms here. Try to think back real quick. What type of factoring goes along with 2 terms? It's DOPS. But you also have to make sure it has the difference of perfect squares set up. Difference means subtraction, which I have, and 9 and 49 are perfect squares, so I'm in the correct setup. Now, it's been a long time since we did DOPS. Big review from the last video. To start DOPS, you take the square root of each of those terms. Now remember what the square root is asking you. It's asking what times itself will get you that number under the square root. So in other words, for this first one, what times itself will get you 9? Well, the square root of 9 is 3. What times itself will get you x squared? X. So the overall square root of 9x squared is 3x. Now same thing with 49. The square root of 49, what times itself gets you 49? Is 7. Now the thing that everyone tends to forget when they're doing DOPS is how you actually take that information and put it into your answer format. Your answer format for DOPS will always be the same, 2 sets of parentheses, plus and minus. You take what you got from your first square root and you put it in the first blank. So 3x goes here and here. Then you take what you got from the second term and plug it in the second space in your setup. So 3x plus 7, 3x minus 7 is the final answer. Can it be checked? Yes, it can. If you want to see how they're checked for all of these, go to my key on Blackboard. Okay, if I checked all of these with you guys, we'd be here forever. That's the only reason I'm skipping over it. I've showed you how to do it a few times now. If you want to see it for each specific example, that's why I'm referring you to my key. Okay. So if this was my quiz, I did a DOPS example, that means I'm not going to see another DOPS example come up. So that's what's kind of nice about the quiz. Once you do it, it's done. So question 270. It has 3 terms, but I don't care about that yet. You always have to see if there's a GCF to start. Between all 3 of those terms, they don't have a GCF other than 1, so I would then move on to counting my terms, and there's 3 of them, so this is definitely a trinomial. Now remember, AC works for all of them. This one specifically works with the shortcut, so it's trinomial easy. So for the shortcut, I'm going to put that negative 63 off to the side and list the factors of it. So 1 times 63, 2 doesn't go in, it's not even an even number. Next would be 3 times 21, and then 7 times 9 is the next factor that goes in. Remember, the goal for any trinomial is to then pick the pair that adds to the middle number, keeping in mind that we're multiplying to a negative for this one, so I need one positive term and one negative term. Take a second to try and figure out what your pair is going to be. It's a super fun math puzzle, and I know you guys are just loving this right now. It's going to be a positive 7 and a negative 9. Because, again, do that quick double check. Your whole answer depends on it. Positive 7 times negative 9 is a negative 63, and positive 7 plus a negative 9 is negative 2. So I go ahead and I write my answer using that shortcut as simply, x plus 7 and x minus 9. Done. I'm going to take you off to the side and show you the AC method for this really, really quickly in case you want to do that instead. So it's x squared minus 2x minus 63. You would do a times c, which would still get you negative 63, and you'd still pick this pair, but the setup and the steps to follow are different. So for AC, your x squared comes down. You split up negative 2x into plus 7x minus 9x, and then the negative 63 comes down. You have 4 terms now, so you group them. Your GCF of the first group is x, so that x comes down, and you divide. X squared divided by x is x, and 7x divided by x, your x's cancel and leave you with a plus 7. Your GCF of the next group is going to be a negative 9, so that minus 9 comes down. These negative 9s cancel each other out, and I'm left with an x, and negative 63 divided by negative 9 is a positive 7. Again, I'm going through this quickly just to show you AC also works and how it would work. So that x plus 7 matches up, so I bring it down as x plus 7, so those are gone. And my two GCFs come together, x minus 9, and notice you get the exact same answer. It obviously has a lot of extra steps, but if you're more comfortable with doing AC or even doing it as a check if you want to, by all means. But Trinomial Easy works if you've got this one in front. All right, 271. A problem that a lot of people have with this one is they count the terms. It's got 3 terms. It's got a number that's not 1 in place of A, so they try Trinomial AC. But remember, you're supposed to check to see if it has a GCF first. This one does. 6x squared plus 9x plus 12 all have a 3 in common. So this one is actually your GCF method. Yes, I know it looks like a beautiful trinomial, and yes, Trinomial AC is tempting, but if it has a GCF, you do the GCF method. So again, going back to that first video, what we did with GCF is kind of what we did within grouping 2, but it's just GCF by itself. They don't have an x in common, so my overall GCF is just 3. So I divide by 3, divide by 3, divide by 3, and I put that 3 out in front. Now that I'm set up, I do the division. 6x squared divided by 3 is 2x squared. 9x divided by 3 is a plus 3x. And 12 divided by 3 is a plus 4. And you are done. Do not do trinomial method if GCF applies. So now going back, so far I've done DOPS, Trinomial Easy, and GCF. That means I'm done with those 3 methods. There's only 2 more methods to go. I look at 272 and I count my terms. I would normally check for a GCF first, but since I've already done it, I know it's not going to be the GCF method. All I have left is grouping and Trinomial AC. So 272 has 4 terms. I'm going to do the grouping method. So I start by grouping my first 2 terms together and my second 2 terms together, and I GCF each group. My first group has a GCF of just y. You can write 1y, absolutely nothing wrong with that. But make sure you bring down that 1y or the y out in front of parentheses and then divide. 2y squared divided by y is a 2y. 3y divided by y, technically negative 3y divided by y, is a negative 3 because those y's cancel. Okay, my GCF for the next group between 4y and 6 is a 2. When I go to take out that 2, I have a problem. Negative 4y divided by negative 2 is a negative 2y, and that won't match up. So that tells me, hopefully we remember, I have to make my GCF negative. If you notice it right away, Awesome. Okay, negative 4y divided by negative 2 is the positive 2y I need it to be to match up. And 6 divided by negative 2 is a negative 3. They match up. Awesome. So I'm good to go and write my answer. I take the one that matched up and I bring it down. Those are gone. And now I take what's left, y and a negative 2, and I get y minus 2. Final answer. So far I've done DOPS, trinomial easy, GCF, and grouping. All that's left is trinomial AC, but let's see why that one applies to this. I have 1, 2, 3 terms, and my number out in front is a 2. It's not a 1, so that tells me I have to do the AC method. The shortcut does not apply. So I start by doing A times C, which is 14. Okay, I list my factors of 14 off to the side, so 1 times 14 and 2 times 7. Of that list, I now have to pick the pair that also adds to a positive 15. So take a second to try and figure out what that pair is going to be. Hopefully we get 1 and 14. Now, I'm multiplying to a positive 14, which means it could be positive, positive, or negative, negative. But because I'm adding to a positive, I want these to be positive as well. So my setup for AC is to bring down the 2y squared, split up that 15y into plus 1y plus 14y, and then bring down my plus 7 at the end. That's the AC setup. Once you're done with this setup, you're going to jump straight into grouping because we just made it so that it had 4 terms. The whole point in that is to give it the grouping method. So of my groups, my first group has a GCF of y. So I have to take out that y, or 1y if you prefer, and put it out in front. 2y squared divided by y is 2y. And 1y divided by y, my y's cancel and just leave me with a 1. My GCF of the next group between 14y and 7 is 7, so I bring that 7 down. 14y divided by 7 is 2y, and 7 divided by 7 technically cancels, but you have to replace it with a 1. Or think of it as 7 divided by 7, it's just 1. These match up, which is awesome. That tells me my answer is 2y plus 1, and then that y plus 7 that's left over comes down together in one set of parentheses. Okay, now a couple things before we do that last example and talk about that link at the bottom. We just did essentially what your quiz is going to look like. You're going to, again, have 5 questions, 1 GCF, 1 DOPS, 1 trinomial easy, 1 trinomial AC, and 1 grouping. So you want to know how to apply each method and when each method applies. I cannot stress that enough. If you don't know when to use the method, you're not going to get it right, okay? So 5 different types of factoring, know how and when to use each one. Now a hint that I gave you for the quiz, like I already said a bunch of times, is you're only going to have one of each type of factoring. That being said, you have grouping right here, which is just grouping you're given 4 terms. But when you do trinomial AC, grouping is involved. So you're going to do grouping here, and you're going to do grouping here. So on your quiz, you should be doing grouping twice. If you are the kind of person that doesn't want to use the shortcut and you want to use AC again for this trinomial, you're also going to use grouping for that. So if you use this method and you have these other 2 examples, you could be doing grouping up to 3 times, but if you use the shortcut, you're going to be using grouping twice. So I just want to make sure that that is stressed to you guys, that even though I said you're going to have one of each type of factoring, grouping lies within the trinomial AC method. So you're at least going to be doing grouping twice. Okay. One last thing that I really want to stress to you guys for your quiz is that every factoring problem can be checked by distributing. Okay, every factoring problem can be checked by distributing. Must it? No. Can it? Yes. Do I advise it? Yes, I want to make sure you guys are getting these right for your quiz. Now, it's set on your calendar all semester, but because we haven't been together to talk about it, this factoring quiz on the week 8 material is going to be a double quiz grade. It's kind of nice for you guys because it is open notes. You can use your resources. Oh man, I keep doing that. Okay, just hear me out while I try and find your stuff again. So while you guys are working on this quiz, while you guys are studying for this quiz, apparently I can't scroll and talk at the same time. While you guys are studying for this quiz, keep in mind it's going to be a double quiz grade. So when your quizzes are normally 10 points, this quiz is going to be 20 points. So you want to definitely take advantage of your open notes and take advantage of the fact that you really need to study for this one. So I cannot stress enough how important factoring is going to be over the next couple weeks. If you don't understand the basics we just went over for week 8, week 9 is going to be mad hard for you. So take your time, practice makes perfect. Go through the homework assignment and practice these procedures on your own. Guys, it's all about the procedure, so it's really important that you go through that, all right? All right, one last example, just a little cherry on top. I told you guys we'd do one more like this. It's not in the right order. It's supposed to be ax squared plus bx plus c. So when I go to put this in the right order, your x squared is going to come down in front. Next is bx, which is this right here. It's negative, so I'm going to bring down a minus 3x. And then that plus c at the end is going to be this minus 40. I checked to see if there's a total GCF here, and there isn't, so this is not the GCF method. This is going to be trinomial, and I count my terms that tell me that it's going to be trinomial. There are 3 terms. So it's trinomial, and I look at this number in front, it's going to be trinomial easy. So off to the side, I just list that negative 40, that's the number by itself, and I list my factors of 40. So 1 times 40, 2 times 20, 4 times 10, and 5 times 8. Now my goal here is to pick the pair that adds to the middle number. Take a second to try and figure it out. It's going to be positive 5 and negative 8. Because again, do that check. Positive 5 times negative 8 is negative 40, and positive 5 plus negative 8 is a negative 3. So using that shortcut, my answer is going to be x plus 5 and x minus 8. Okay, to all of my math nerds out there, happy pi time. It is 314. Remember, pi is 3.1415, blah, 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 blah. So now that it's 314, at least on my end, it's not for you, but happy pi time for me. All the examples, keep in mind everything I told you about your quiz. They're going to be mixed up. You need to know how and when to do each type of factoring. It is a double quiz grade, and they're not exact questions from your homework assignment, but it is open notes, and you can check every question by distributing. Okay, so important. If you want some fun while you're sitting at home, clearly bored because math is over, you can watch this video. Teach me how to factor, teach me how to factor is basically what this link is going to lead you to. So it's quite fun, entertaining for you guys. By all means, take a second to watch that if you're bored. It's not mandatory. You're not going to be quizzed on it or anything, but definitely just take a peek if you're bored. Remember your code word. Make sure you wrote that down throughout the video. And good luck practicing with your homework. If you guys have any questions, please reach out to me by email or set up office hours, or come to regular office hours, Tuesday, Thursday, 3:15 to 4:15, or you can set up a different appointment if that doesn't work for you. Those are going to be done on Blackboard Collaborate. Okay? Have a great day, guys. Good luck.